So we're just almost done with our introduction to the t statistic to do hypothesis testing and to make confidence intervals. We have some guidelines. We set the assumptions. We're a simple random sampling, a normal distribution, a normal population distribution. And that the sample is small compared to the population. Okay. And we've said before that really you always have to have simple random sampling or something like it, so you can't get away with not having simple random sampling. This ordinarily isn't a big problem. Ordinarily the sample is small, so that's usually true. Here's the deal. The population might not be normal. That happens more than you'd care to say. Yeah. So we'll talk about what the population has to look like and what sample sizes you're allowed to use. Of course, we don't usually know the population distribution. We just have the data that we sampled. And we're just using that. If we knew all about the population, we wouldn't be doing the test at all. So it says here, if the sample size is less than 15, the data, so you make a stem plot or a histogram or something, it must appear close to normal. That means roughly symmetric, single peak, no outliers. Of course, with small samples, it'd only be roughly symmetric, and it would look like it has one peak, but there might be jaggies in there, and it's sometimes hard to tell. There'll be gaps, but they may not be considered outliers. You have to make a judgment call. Does this look like data that could have come from a normal distribution? And that could be difficult to assess, and you just have to use a gut reaction. If you don't see clear evidence of outliers, or clear evidence of two peaks, or clear evidence of skewness, then you're allowed to use the t-distribution with sample size less than 15, even as low as 9, like we did with those increases in test scores. If n is bigger than or equal to 15, we're not as worried. No outliers, no strong skewness. So it doesn't have to be completely symmetric, doesn't have to have a single peak. No outliers though, and no strong skewness. So it can be slight skewness. And then with n as large as 40, 40 is pretty big, the central limit theorem starts to kick in, and really you get a close to normal distribution. And t itself is, because it's got that sample standard deviation in the denominator, if you have a distribution that's not normally distributed, that sample standard deviation sort of counteracts the things that go wrong in the normality of the sample mean. So even though the sample mean might not be very close to being normal, if n is somewhere around 40, if things are really bad in the population you're sampling from is not at all normal, the way the sample standard deviation works is it helps to stabilize that t-statistic and allow you to use it even though x bar is only roughly normal and not very close to being normal like you might have in other cases where you had a normal, approximately normal population. Then n is 40, x bar is pretty much normal. So if the population is very skewed with outliers and n is only 40, you might see deviations from normality where x bar, the distribution of x bar might be skewed. And the fact that we're using the sample standard deviation actually helps, because when it's skewed, the sample standard deviation tends to be too big, and that balances out the things that go wrong with x bar minus mu naught on top of the t-distribution. That's all technical stuff. We just want to know what to do. When n is at least 40, use t. Don't worry. When n is bigger than 15, it shouldn't look crazy. When n is less than 15, it should look like the data you collected. It should look like it came from a normal distribution, single-peaked, symmetric, no outliers. All right, we've completed our entry into the fray of looking at some statistics, the t-statistic, that you can actually use with data you collect from an experiment. You could now use that in biology and chemistry, other places, to talk about where we think the mean is or whether that mean could be a certain value. Yay! We'll be back soon with the conclusion of the semester. We have a couple more chapters to talk about, I believe, but I'm done with videos for chapter 20. Yay!